Alright, today we're covering 3-6, which is lines in the coordinate plane. Remember to take notes and do the check it outs and write down any questions.
Our two learning targets today, I can graph lines and write their equations in SlopeIntercept Form and Pointslope Form. And I can classify lines as parallel, intersecting, or coinciding.
So the two forms of an equation of a line that you're going to have to know are point-slope form and slope-intercept form. So point-slope form, if you have your slope of your line, which is m, and we know how to calculate slope, we've been working on that, and you have your coordinates of a point, which are x1 and y1. This is your equation. You would plug your slope here, your coordinates of your points here and here. So it's y minus y1 is equal to m times x minus x1. Don't forget the parentheses around your x minus x1, because when you want to simplify this, you will distribute your slope across those two variables. Slope-intercept form is the one that we're more familiar with. Y is equal to mx plus b. Again, m is our slope, b is our y-intercept. So that's where the line crosses the y-axis. So here's the form of the equation.
Okay, so as Ms. Briscoe had, we talked about the point-slope form and the slope-intercept form on the previous slide. So an example of those two, you can write these into your notes. And then we talked about this in our last lesson. The equation for a vertical line is x equal a, where a is your x-intercept. And the equation for a horizontal line is in terms of y equaling, and this is y equals b, where b is your y-intercept. So where it's crossing the y-axis for your horizontal line, and where it's crossing your x-axis for your vertical line. Examples for each of those lines are there.
All right, we're going to go through some examples of writing equations for lines in various forms given different information. Okay, so I've worked out the first example. Again, it's nice to label your points x1, y1, x2, y2, so you don't get them mixed up when you plug them into the slope formula. So that's going to give us a slope of 2 minus 0 over 1 minus the negative 1, 2 over 2, which is 1. Now I plug that into my y equals mx plus b formula right here. So I have y equals 1x, 1 was my slope, plus b. Now I'm going to take either of these points, one of these points, so it doesn't matter which one. In this case, I took these 2 points. I plugged my x1 in here for x, and I plugged my y1 in here for y, and that's what I did over here. And so 0 is equal 1 minus 1 plus b. This simplifies to 0 equals negative 1 plus b. I add 1 to both sides and get a b or y-intercept of 1. And so, and I didn't write this correctly. I actually forgot to fill in the fact that my y-intercept is 1. So the equation of that line would be x plus 1. All right, this one, b, we want in point-slope form. And we know it has a slope of 6, and it goes through this point. All right, second example was much easier. The slope is 6. Here's my x1, my y1. So I plug them into the point-slope form. Y minus y1. So y minus the negative 4 is equal to my slope times x minus x1. And the only thing I can do is simplify this negative of this subtraction of negative 4. Negative of the negative becomes plus 4. So it ends up being y plus 4 is equal to 6 times x minus 3. Okay, our last example, point-slope form. X-intercept is 3, y-intercept is negative 5. All right, so the trick to this one is remembering that x-intercept basically has coordinates. It's a point of coordinate 3, 0, and the y-intercept is going to be a point of coordinate, in this case 0, negative 5. So I have my x1, y1, and even though I didn't write it here, this is my x2, y2. Plug it into my slope formula. I'm going to get a negative 5 minus 0 over 0 minus 3, which becomes 5/3 is my slope. And now I pick one of these points to plug into my point slope form. I picked this one. And so now I've got y minus 0, that's my y1, whoops, is equal to my slope 5/3 times x minus 3, which is my x1. I can simplify y minus 0 to be y, so my final equation, y equals 5/3 times x minus 3.
Okay, now it's your turn. You've got two problems here. One first one in SlopeIntercept Form, the second one in Pointslope Form. Good luck. Bring me questions to class.
Okay, so now we're going to graph lines given equations in various forms. First one is y equals 1/2 x plus 1. So remember, this is our slope, this is our y-intercept, and we're going to use these to graph the line. Okay, so I put a point at my y-intercept of 1. I went up 1 over 2, made another point, and then drew a line through it, and we have our line of y equals 1/2 x plus 1. For the next one, it's in point slope form. So remember, this is going to be our slope here. This is going to be our slope here. And our point are these coordinates, and we'll use that to graph our line. Okay, so I rewrote point slope form right here. So we remembered what it was. And from here we can see that our slope is -2. Our y1 is 3. Our x1 is a little bit tricky because it should be x minus 4. So since this is positive, that means our original coordinate was a negative. So -4, 3 was one of our point. So I made my first point at -4, 3. And then my slope is 2, so I went down 2 and right 1, and then I drew my line through those 2 points. All right, so remember from a couple slides ago, an equation of the form y equals some constant is going to be a horizontal line. So I drew the line here, found where y is equal to -3, and just drew a straight horizontal line through that.
And now it's your turn. You have 3 check-it-outs, or 3 problems to check it out to graph the line of these 3 equations. Good luck. Bring any questions to class.
All right, so we can classify pairs of lines by looking at their form, and you probably want to put them in slope-intercept form because it depends on looking at the slopes and the intercept. So parallel lines, if we look at these 2 equations, what do they have in common? Well, the slopes are the same, but notice the y-intercepts are different. So same slope, different y-intercept means the 2 lines are parallel. Intersecting lines, if you look at these 2 equations, you can see neither the slope or the y-intercept is the same. But the key part here is that the slopes are different. So if the slopes are different, then that means that the lines are intersecting. It doesn't matter what the y-intercept is. And our final case then would be equations that look like this, and they may not look like this, but if you put them both into slope-intercept form and simplify them, you can see that these 2 equations are exactly the same. So that means the lines are coinciding. So if they have the same slope and same y-intercept, they're coinciding lines. Basically, that means they're the same lines. All right, so to summarize, a system of 2 equations with 2 variables, so we usually have x and y. They can be parallel, intersecting, or coinciding. Sorry, this is what I meant. Or the lines that coincide, not or, but lines that coincide are the same line, but their equations may be different. There, now you can see it all. Isn't that fun? The way we can move those around. So anyway, lines can be parallel, intersecting, or coinciding, and lines that coincide are the same line, but the equations may be written in different forms, so you need to be careful.
Okay, so here's an example. We want to classify the pairs of lines. So for the first lines, we're looking at the equation y equals 3x plus 7 and y equals -3x minus 4. So we want to look at the slopes. Right now, our slopes are both different. As a result, that means our lines are going to intersect, so these would be intersecting. Our second example, we have y equals negative 1/3 x plus 5 and 6y equals negative 2x plus 12. So as Ms. Briscoe said, put them in slope-intercept form. Our first equation already is. Our second equation, we need to solve it for y. Okay, so putting both of the equations in slope-intercept form, we notice our slopes are the same. Both are negative 1/3, and our y-intercepts are different, so our lines are going to be parallel. In our last example, 2y minus 4x equals 16, and y minus 10 equals 2 times the quantity x minus 1. Neither of these equations are in slope-intercept form, so let's solve both of them for y. Okay, so solving each of these and putting them in slope-intercept form. First equation, we get y equals 2x plus 8. And our second equation, y equals 2x plus 8. The equations are both the same, and so these are coinciding lines.
All right, so to wrap up this lesson, you have one more check it out to do. Try it out, and we will see you next time.